Hello everyone, my name is Komasinyolo. Welcome to another video by Attention Matrix, where we try to make learning fun and easy. Please comment, like, and subscribe if you would like us to continue making this content and you enjoy it or find it helpful. Now on to the next video. Let's get right into it.
Okay, in this video, we are going to focus on, we're continuing our lessons on functions, and in the specific video, we're going to be focusing on the parabola, okay, on the parabolic function or the quadratic function. Okay, so the quadratic function, I'm going to explain the three forms that it can take, the three standard forms that it can be expressed in, and I'm going to explain each of those three standard forms individually. Okay, so we've got three standard forms of the parabola. The first standard form is y is equal to ax squared plus bx plus c. Okay, this is the first standard form that we can express our parabola in. The second standard form is y is equal to a open bracket x minus p all squared plus q. This is the second form, and the third form that we can express our parabolic function is y equals a x minus x1 close bracket x minus x2. Okay, now these standard forms might be expressed in different letters. Usually the first one that you see here, usually this one, everybody expresses it the same way, all right? But, and then usually with the second one, almost everybody uses P and Q there. But they might be expressed slightly differently by different people, which might lead to you having to tweak your interpretations of the equations that I'm going to give you in this video. But essentially, they mean the same thing. So, for instance, some people might use M and N here, or they might use some other letters, and some people might use a plus here instead of a negative. But depending on how the people actually express these equations, you should tweak your interpretation to suit those definitions. But ultimately, in essence, all the definitions are the same, right? You just have to understand what you're doing. Okay, so these are the three standard forms. I'm going to explain the first form first. Okay, so the first form of the equation. Okay, so the first form of our parabolic function is as follows. I'm just going to underline. Oh, I don't need to underline. So we've got that first form. That's y is equal to a x squared plus b x plus c. Now in this equation, we've got certain parameters that we need to understand. The parameters that we have are a, b, and c. Okay, those are the important parameters that we have to understand in this equation. What do each of those parameters mean? Now, let's start off with A. A just tells you the direction of your graph. Okay, so I'm just gonna draw in a Cartesian plane so that I can explain. So your parabolic function, remember what a function is, right? A function is basically a graph that has one unique y value for one or more x values. We covered that in a separate video. Now, your parabolic graph will either have a cup shape, or it will be concave up, or it might look like that. Okay, going down like that. So it might have a smiley face, which is the first one that I drew, or it might have a sad mouth, sad face, the reverse of a smile. Okay, so now A in this standard form. A in the standard form simply tells us if our equation will look like that, or if our equation will look like that in terms of the direction that it is following. Okay, that's what A tells us. The sign of A, tells us if we will have a smiley face or a sad face, right? An upright smile or an upside down smile. Okay, so if A is less than 0, in other words, if A is negative, less than 0 simply means negative. If A is negative, then our graph will be sad, right? You can think of negative emotions. So negative emotions, if you're sad, if whatever, just think of negative emotions. You associate negative emotions with a sad face, right? Sad face, it goes down. So if it's negative, think of negativity, negative emotions, negative situation. You're not going to be happy, you're going to be sad. So you're not going to have a smile, you're going to have a frown. It's going to be upside down. Your smile will be upside down, right? If A is greater than 0, if A is greater than 0, then you will be in a great mood, right? You'll be in a good mood. So if A is greater than 0, it means it's positive, meaning that you've got a smiley face. You've got a smiley face. Your graph has a local minimum. It has a minimum, and your graph goes up. It goes up. Okay, so that's what A means. Now let me just give you a couple of examples before I move on to B and C. So let's say you've got a simple parabolic equation or a parabolic function. Let's say you've got y is equal to minus 2x squared, right? Minus 2x squared. Now, never mind the fact that I don't have anything else here. Remember our standard form. Let me just scroll up so that I can. Yeah, there's no space to write in a standard form. So what I'm going to do is I'm going to erase this. Then I'm going to write in the standard form first before I actually write down the example. So our standard form is y is equal to ax squared plus bx plus c. Right, if I have an example, I say y is equal to minus 2x squared. That minus 2 there is our a. How do we know that minus 2 is our a? Because the minus 2 is tied to the x squared. It's tied to the x squared. So a in the standard form is tied to the x squared, meaning that whatever value is attached to the x squared is our a. So in this instance, minus 2 is our a. Right, now if I were to ask you what shape would this equation, with this graph have, you would tell me that because it has a negative, because a is negative, a is minus 2, therefore a is negative, right? A is negative. Negativity means unhappy, sad emotions, sad situation. So the shape will be doing that. The graph will be going downwards, in the downwards direction. Okay, so if I were to just ask you for the shape, so far we're not sketching. We're going to sketch all these graphs in subsequent videos, but now I'm just explaining the fundamentals, the basics of these standard forms. Okay, so from this you would be able to tell me the shape is that one. Okay, now what if I were to give you y is equal to minus 4x squared plus 2x minus 8 or something like that. Okay, I don't know, this graph might exist or it might not exist, but I just want to illustrate the concept. Let's say I ask you, what is the shape? What is the shape of this graph, right? What is the shape of this graph? Remember what our standard form is. Our standard form is a, let me just write it in full, y is equal to x squared plus bx plus c. Okay, this is our standard form. Since our standard form, we know that a is the value that is attached to the x squared. Which value is attached to the x squared here? The value that is attached to the x squared here is minus 4. Minus 4, so a is equal to minus 4. So a is less than 0, right? A is negative because it has a negative sign there, meaning that our graph the shape of our graph will look like that. Okay, I'm not drawing it on our Cartesian plane, but it will look like that. It'll be concave downwards. Okay, so that's what. Let's do one last quick example before we move on to B and C. I'm actually gonna do B last. Okay, so let's say we've got y is equal to 10x squared plus 100. Well, we know that our standard form is y is equal to ax squared plus bx plus c. A is the value that is attached to an x squared. The value that is attached to an x squared here is 10. Therefore, a is equal to 10. Right? So a is positive. A is greater than 0, meaning that it's positive. So the shape of our graph will look like that. Our graph will go up like that. Okay, so the whole point of me explaining what A is means that just by looking at A, you can tell the direction of your graph, that if it's either going up, a smiley face, or it's either going down, a frown or a sad face. Okay, so that's what A means. Okay, now what does C mean? What does C mean? Let's deal with that next. Let's address C before we move on to B. B will address last. Okay, so now what does C mean? Okay, our standard form, again, y is equal to ax squared plus bx plus c. Okay, so we know what A is. Now let us address what C is. What is C? Now C is our y-intercept. Okay, C is our y-intercept. C is our y-intercept. Now, what is our y-intercept? I covered this in a separate video, but I'm just going to explain it again. Y-intercept is the y-intercept is the y value. That's the y value through which the graph passes. Okay, that's the y value through which the graph passes. So I'm going to explain that graphically. So if you've got your Cartesian plane like that, and you've got some parabola. There's your parabola there. Now, your y-intercept would be the value of y at that point, right? The value of y through which the graph passes on your y-intercept. Actually, I think my what do I say here? Y value through which the graph passes. It's the y value through which the graph passes on your y-axis. Okay, on your y-axis. On y-axis. Okay, so that completes the definition. So when you look at that, you can immediately see that, okay, so the y-intercept is that value there. So this is your y-axis, right? And on your y-axis, you have a value for y. And because the graph passes through that value on your y-axis, then this is your y-intercept. Okay, this is your y-intercept and this is your c. Okay, so let's go back to the previous examples that I looked at. Okay, which was the first example that I looked at? This was the first example. I was asking you about A. What is C in this particular example? So in this equation here, what is C? C is minus 8, right? C is minus 8. Why is C minus 8? Because that's the number that stands on its own, the number without an x. So if you look at the standard form, right? If you look at the standard form, C is the number that stands on its own. It does not have an x, right? It doesn't have an x. So any number in your quadratic function or your parabola or your parabolic function, any number that is not tied to an x is your C, right? And you must also pay attention to the sign. C in this case is minus 8. Minus 8, not just 8, it's minus 8. You pay attention to the sign. Okay. And if you look at this equation here, the second example that we looked at, this is the second example that we looked at. Our standard form is ax squared plus bx plus c, right? C is the number that stands on its own. Which number stands on its own here? Well, the 100, right? The 100 stands on its own, so C is equal to 100. This means that if you were to plot this, your graph would cut through the y-axis at y is equal to 100 on your y-axis. Okay, on your y-axis. Let's move on to the next one. Okay, I missed an example. Where was the other example that I looked at? I recall looking at minus 2x squared. Where is it? Okay, it's fine. Let's look at another example. Now, if you've got this example here, let's say y is equal to minus 2x squared. Remember what our standard form is. Y is equal to ax plus bx plus c. What is c in this example? In this example here, this example, what is our c? Well, if you look at this example here, we've got minus 2x squared, but this is all that we have. Remember, I said c is the value that is not connected or tied to an x, right? It's not tied to an x. There's no x with the number. So in this case, we've got minus 2x squared. What is our c value? Well, if you look at this equation here, there is no value that is tied to a c. There is no value that is not tied to an x, right? There is no value that is not tied to an x. In other words, we don't have a c here. So in other words, for this equation, c is equal to 0, right? C is equal to 0. What does this mean? This means that if you were to plot this graph, I'm just going to draw a tiny Cartesian plane there. You plot this graph. Remember what we said A is. A in this case is a negative 2, right? So our graph will look like that. That's the shape of our graph. Our shape of our graph will look like that. And remember what we said C is. We said C is the point on your y-axis through which the graph passes. So we know two things about our graph. We know firstly that our graph will pass through there because that's the y-intercept. That's where y is equal to c, which is equal to 0, right? Because this is the y-intercept, right? The y-intercept is at c is equal to 0, right? So then our graph, we know that our graph will pass through there, and we know that our graph will have a shape that looks like that. I missed it there. A shape that looks like that. So, I'm lying. It's a shape that looks like that. Because A is negative, it's a shape that looks like that. Okay, so our graph will basically look like that if we had to estimate it roughly. So that's what C is. Basically, C is at that point. How do I know that C is at that point? Because C is 0. So on your y-axis, it passes at a point where y is equal to 0. Okay, so that's what C is. Remember, C is your y-intercept. Y value through which the graph passes on your y-axis, or the y value through which the graph cuts the y-axis is another way you could express that. Okay, So that's it for A, that's it for B, and that's it for C. That's it for A and B. Now what is B? What is B? Okay. They shouldn't ask you too much about B, but B essentially tells you um, uh, how thin your graph is. Okay, so how thin your graph is. So if you've got so the bigger your B, the thinner your graph is. So you could have several graphs. You could have a graph that looks like, I'm not going to dwell too much on B because you're not going to get asked too much about it, but you could have a graph that looks like that, right? You could have a graph that looks like that. You could have a graph that looks like that. I want them to hit the same point. Okay, you could have a graph that looks like that. Cuts through the, see what's happening, it's getting thinner and thinner. I'm drawing them to be I'm intentionally drawing them to look like this, thinner and thinner. Or you could have a graph that looks like that, right? And the other direction is also, it's also true for the other direction. So the bigger you make your value of B, the thinner your graph is going to be. So in other words, for this case where your graph is positive, that graph there will have the biggest V. And as you move towards that direction with that end and towards that direction, then the smaller your value of B is. Okay, so that's just it's on the side. They're not actually going to ask you a lot about this. So if you are curious, you could seek out information about it. It's readily available, and actually more than what I've said here is actually the case. Okay, so I'm not going to dwell too much on that. Main thing that you should understand is A and C. Okay, so that's it. Basically, that's it for this for the standard form. The standard form there. Okay, so I think let's look at a couple of more examples, and then I will cover the second standard form on a separate video. I'm not going to cover them in the same video. Okay, so it's just so the different standard forms are easier to find when you look for the videos later on. I'll cover them on separate videos. So let's say now you've got a couple of equations. Let's start with one. Y is equal to x squared. Okay, let's say 2, and then we ask you to sketch these equations very roughly. Okay, let's say y is equal to minus x squared. Let's say 3, y is equal to x squared plus 1. 4, let's say you've got minus x squared minus 2x. Okay, these are very simple. Remember, these videos are to cover the very basics, the very fundamentals. Okay, more complex problems and questions might be addressed on separate videos, or you can contact us for personal tutorials. Okay, so let's cover them one by one. So I ask you to sketch these I ask you to sketch these functions. So that's the question. Sketch them. Sketch the equations, or sketch the functions. Okay, sketch the functions roughly. So that's the question. So you don't have to be exact, you don't have to do any calculation. I just want you to get used to figuring out how these graphs look quickly, right? Quickly, so that you can solve questions quicker. We're gonna do detailed calculations in future for subsequent videos, but for now we're just just teaching you how to interpret these things quickly. Okay, so first thing you will notice is that the standard form. The standard form of these equations is y is equal to ax squared plus bx plus c. Okay, that's the standard form. Now, the first one there is y is equal to x squared. Okay, now if you were to sketch this, the first two things you would look at is the shape of the graph and the direction of the graph and the y-intercept. What is the y-intercept for this equation? Well, there is no number that floats on its own in this equation here, right? If we're looking for c, there is no number that floats on its own, so it means that c is equal to 0 because there is no number that is not tied to an x in this equation. So c is 0, so we know that our graph will cut through there. That's where our y-intercept will be. And then we see that our a in this case is 1, right? If you don't see a number, then it's 1 next to the x squared. A is 1, meaning that this a there is greater than 0. So a is greater than 0. In other words, a is positive. A is positive. It has positive emotions. It's life is good. So what does positivity mean? It means a smile, right? Smile goes upwards. So then your graph would pass through there, but then it would go upwards like that. Okay. So that is what your graph would look like. Let us do the second example. So this is what your graph would look like here. Let us do a second example. These are very simple examples. Okay, your questions that you're going to get are much more complicated than this. So the second example is y is equal to minus x squared. Okay, now what is our a here? Our a is less than 0. In other words, our a is negative. Our a is negative. So we know that our graph will be sad because our a is negative. Negative emotions are bad. Bad makes us not smile. It makes us frown. So our graph will be going downwards, right? And our c, same as the last one, our c is 0 because there is no number that flows on its own here, right? So then if you were to quickly sketch this, then what you would get is it passes through there because that's where your y is equal to 0 and it's negative, so it goes down like that. Okay, goes down like that. Okay, so let's quickly do the next one. The next one is y is equal to x squared plus 1. Y is equal to x squared plus 1. Y is equal to x squared plus 1. Now a here is 1, right? A is equal to 1, so a is greater than 0 because 1 is greater than 0, meaning smiley face, right? Then y is c, meaning our graph will cut through the y-axis at 1, right? So if we have a 1 here, then this is where our graph will cut our y-axis, and then it has a smiley face, so our graph will look like so. That's what our graph will look like. Okay, then the next simple example was minus x squared minus 2x. Minus x squared minus 2x minus, okay, just y is equal to minus x squared minus 2x. Okay, so this graph here is a bit different. I'm not going to draw it on a Cartesian plane because I haven't explained the y-intercepts and the x-intercepts yet. I'm going to explain that in a bit. I'm going to explain that in the next video, actually. So I'm going to continue on with the standard form in the next video, but where I'm just explaining the intercepts, okay, because we're going to have to do a bit of factorizing. But if I had to ask you the shape, just the shape, I'm not going to draw it on a Cartesian plane. Watch the next video and then come back to this video and see if you can sketch this graph, right? So here, the shape, you would tell me that A is less than 0. So A is negative. Why? A is equal to minus 1, right? So A is less than 0. Because it's equal to minus 1, A is negative, so then it's frowning because it's not feeling positive emotions, it's feeling negative emotions, so it's frowning. So actually this thing might confuse you. Now you might think I'm drawing the parabola, I'm just pointing. So the shape of the graph will look like that. It'll be going down like that. And then what is our C here? Our C in this instance is 0, right? Because we don't have this, the negative 1, there's an x squared here, there's an x there. And then there's no number that's floating on its own. So C is 0. So then your graph would pass through. If you were to draw a Cartesian plane, your graph would cut through there. Okay, it would cut through there, but I'm not going to draw it on here because I haven't explained x-intercepts and y-intercepts yet. Well, x-intercepts yet. Okay, so this is basically what A, B, and C mean. Okay, it's very simplistic definitions. You'd have to do a lot of practice to get used to different kinds of questions that they might ask you. They're not going to ask you the types of questions that are asked here. This is a video for me to explain the very basics, the fundamentals. Okay, so in the next video, I will cover still the standard form, this first standard form. I'm still going to be looking at that first standard form, but I will be looking at actually sketching out the graphs, finding all the information you need to sketch out all the graphs. Okay, so till I'll catch you in the next video. Lesson number one, lesson number one. Lesson number one, lesson number one.